sponsored by PCBWay. PCBWay is an online PCB manufacturer, and the way it works is you can open your PCB maker website, which for this case I'm using EasyEDA. Over here, my PCB. I can open the 3D view. This is what it would look like. And I come over here. I put in my PCB's .zip file. They'll give me a quote, and if the PCB is built correctly, you could place your order. Over here is a PCB that I have. This PCB is roughly 6 centimeters in length and 3.8 centimeters in width. The way my PCB works is I have the Arduino Nano, which is the microcontroller, and the Arduino Nano lands in these pins, and at the top you have your input pins, which are pushed outwards with the ground and 5 volts connected next to them. This is to reduce the amount of wires. As you can see over here, there are no external wires apart from the power source wires. On the top right, you have the ground and 5 volt plus for the servo motors, and at the bottom right you have the ground and VIN pin. The 5 volt plus and the VIN pin are not connected. However, the 2 ground pins are connected, as shown at the bottom of this PCB, where you can see these 2 are connected. The reason they're connected is because it's important to have a common ground when you're building a robot like this, and that's the reason for that. In the link, in the description, there will be a link to PCBWay where you can order your PCBs. Currently, there's a 50% off sale going on. You guys should definitely check that out. So check out my channel for more robots, and check out PCBWay for more PCBs. This robot utilizes a walking gait known as trotting. The way this walking gait works is you can imagine this being your back left leg, and this being your front left leg, or the same leg on the same side. So this would be the red one, and this would be the blue one. The dots over here represent the base, so this and this. And the way it works is the back wheel goes down in the first section of the code, while the second one goes up. Now this happens simultaneously. Now this dot is up here, and the red dot is touching the ground. And yeah, this could be your ground. After this leg goes forward, this leg goes backwards, and when it's going backward, it's touching the ground, and that causes it to move forward. The fourth section of the code makes this one drop down, sort of like this, and this one does this section where it goes up. The last part of the code, this one goes back to the original position, and this one goes back to its original position. This rectangular pattern is what causes the robot to move, and these are both simultaneous. So you can imagine this one is the same as the leg back here, and this one is the same as the leg at the top left. This can be observed in the robot when we turn it on. As you could probably tell, these 2 legs were moving at the same rate, and these 2 legs were moving at the same rate, and these 2 legs were moving in the opposite direction. So if this one was going forward, this one was going backwards, and that causes it to push itself forward. This robot utilizes a custom-built PCB to handle all 8 servos. As you can see, the servos are connected on the left side over there, and the Arduino Nano is in the middle. It has 8 Metal Gear servos, which require 2.5 amps of current in order to make them function correctly under load. Right now I'm using 2 7.2 volt batteries connected in series. Each battery is 2 amps, which makes it 4 amps, and the voltage remains 7.2 volts. At the back I have my battery connections. The black and white wire are the ground for the brown and white wires are ground for the 2 batteries, which are connected in series. The little black wire at the tip is the switch. the switch is also connected to this green wire, and the green wire is connected to the ground section of the PCB down there. Next to the green wire is the yellow wire. The yellow wire is connected to the 5 volts or the 7.2 volts of the 2 batteries. That powers the servos, and the yellow wire is not connected to the Arduino, because if it was connected to the Arduino, then the robot wouldn't work. The power would be distributed unevenly. There's also this 9-volt battery. This is what powers the Arduino Nano, and it connects to this black and white wire. The black and white wire is the ground and 9 volts for the Arduino Nano. All the parts for this robot are 3D printed from my 3D printer, which is right there. And the links to everything, including the code and the Gerber file, will be in the description.